shared with you? Have you tried the problems? Because I can see problem sheet 5 till 5 you got that sheet, right? And we are supposed to discuss sheet number 4 from sheet number 4 because in the last tutorial class, whenever we have discussed, it was sheet 3 was completed. So that the topic was linear functionals. So have you tried the problems of sheet 4? Because right now we are going to discuss those problems. So please,
Yes,
if
sir.
yeah, yeah. So if you've tried, then one can answer. Okay, so all of you, please just open your sheet 4 with you, and you can ask your doubts. So is my screen visible to everyone?
Yes, sir.
Okay,
Yes, sir.
all right. So okay, so I hope that you have understood this. What do you mean by linear functional dual and double dual? Okay, so how about this question 1? I mean, how will you justify? Okay, so here you have to find this f of v in terms of this f. F is a linear functional on R3, and this v1, v2, v3 are defined by these vectors. Okay, the underlying vector space is R3 over R, and you need to find this f of v. So how will you do this? I mean, what is the basic idea first? Because you have tried, right?
Sir,
Yes, sir.
V1, V2,
Sir,
and V3 are Li
so
vector of R3, and it is basis.
Mm-hmm.
Then A, comma B, comma C can be written as the form of linear combination of alpha 1 V1, alpha 2 V2 plus alpha 3 V3. Now we have read f of V. Then alpha 1 f of V1 plus alpha 2 f of V2 plus alpha 3 f of V3, and f of V1, V2, and V3 are given. Hence we done.
Yes, good. It is correct. So that the very much which I wanted to tell you, that is fine. That is one way you can do, because these values, because f is a linear functional. So this alpha 1 goes outside, and this f of v1, f of v2, and f of v3, these values are given to you. So in that way, you can find these this f of b vector, because this v is abc. Okay. So in the solution, you can write this reasoning. And how about this B problem, part B? How will you write this linear functional explicitly? Where these conditions, this f of v1 equal to 0, f of v2 equal to 0, but f of v3 is not 0. That is given to you. Because so in part A, the answer which you just told me, so it is like some more restrictions imposed over here, right? So instead of this, so here f of v1 equal to 1, but here f of v1 equal to 0. So these two terms got changed, but here f of v3 is not 0. So the same idea, it is not very different. So you can apply the same idea, and you may get the solution. So how to do this? Because
sir,
it is
f of v3 equals to a non-zero equals to x a non-zero constant लेके solve.
uh, to try. Yes, but that, yeah, that is correct. So here I have also mentioned this m. So where m is that is a non-zero constant, which is f of p3 equal to that. So here you can represent this f of abc in terms of this, and of course this alpha 3. This okay, so this alpha 3 is a some constant. Now what about the C part? Now here you can write, I mean, okay. So earlier our vector was ABC, okay.
The C part is
So
same
ABC का वैल्यू
as B.
पुट
सर जब हम V को सर V1 V2 V3 में सपोज मान लिया कि 3 वेक्टर हैं आर क्यूब के जो स्पैन कर रहे हैं आर क्यूब को, तो वो जब हम
Right.
V इक्वल टू अल्फा 1 V1 अल्फा 2 V2 अल्फा 3 V3 लिखेंगे, तो जब हम ऑपरेट करेंगे एफ ऑफ V को, तो सर जो अल्फा 1 डॉट एफ ऑफ V1 तो वो 0 है और एफ ऑफ V2 भी 0 है, तो उससे हमको मतलब नहीं निकलेगा। तो हमारे पास क्या आ जाएगा, एफ ऑफ V इक्वल टू अल्फा 3 एफ ऑफ V3 एंड अल्फा एफ ऑफ V3 इज नॉन जीरो।
Okay, that is fine. So you just okay, I understand that you understood the problem, but what about every one? I mean, others other than you. So is it fine, this problem C part of this question 1?
Yes, sir.
Yes, sir.
So here I can see more the students. There are what about Bharti? Bharti, is it fine, this question? Nitin? Because you are in live class, so you can interact. I mean, the main idea about this is this. Okay, so this question is also not very difficult. So instead of this ABC, here this alpha 3 equal to m, and this you have to show this f of v3 is equal to 0. So if you put this 2 3 1 over here, then you may end up in this kind of linear system. Okay, and if you find this value alpha 1 alpha 2 alpha 3, then this alpha 3 is equal to -4 that comes out. If you solve this, then you can show that okay, this is non-zero. Okay,
सर इसको डायरेक्टली बी पार्ट से शो नहीं कर सकते, ये पूरा प्रोसेस करना पड़ेगा।
that direct B part से. So what about in this B part?
सर बी पार्ट में हमें एक टी वी की एक वैल्यू मिली थी, उसमें ए बी सी की जगह जो यहाँ पे वैल्यू है हमारे पास 2 3 -1 वो पुट कर देंगे तो -3 के आ रहा है, के हमें नॉन जीरो ऑलरेडी पता है, तो ये पूरा टर्म नॉन जीरो आ गया, तो डायरेक्टली ऐसे भी कर सकते हैं ना?
Directly you can say in that way also, but here this because this 2 3 1 2 3 -1 is given, so I have just shown you the how can you do it in the other way also, because here this f of for this ABC, this alpha 3 dot m that is you have, but how do you know this alpha 3 is non-zero? Okay, so do you understand what I am trying to say? So this m is non-zero, that is fine, but what about this alpha 3? If alpha 3 is 0, then how will you say?
Okay, sir.
So in the previous question, so okay, we come back to this part 2. So one student is answered this part 2, and how will you ensure right now here this alpha 3 is non-zero?
सर ऊपर गिवन है ना V1 V2 V3, वहां से वैल्यू निकालेंगे अल्फा 1 अल्फा 2
V1 V2
अल्फा
V3
3
तो LI है ना?
हाँ,
इसका मतलब अगर V1 V2 V3 LI है तो अल्फा 1 अल्फा 2 मतलब इनका लीनियर कॉम्बिनेशन 0 के इक्वल होगा तब जब अल्फा 1 अल्फा 2 और अल्फा 3 कॉन्जिक्यूटिवली 0 के इक्वल होंगे।
राइट, यस।
और क्योंकि हमें दे रखा है कि वेक्टर 2 3 -1 है जो कि नॉन जीरो है, तो इसका मतलब
Right.
अल्फा 1 अल्फा 2 अल्फा 3 0 नहीं है।
Okay, so yes. So then you have to show, if you want to use this problem 2 in 3, then you have to show this alpha 1 alpha 2 alpha 3, this set is Li. I mean, that much you have to show. Okay, and if you don't want to show that, then you can just write in this way, and you find this alpha 1 alpha 2 alpha 3 explicitly, and then you can say this f of p3 is non-zero. Okay, So there can be 2 ways. So what about this question number 2? How will you show this? Because first let us understand what is the question. So this f1 to fm, these are the linear functionals given on this space Cn, and we define a linear transformation from Cn to Cm by this T of B equal to f1v up to fmv. Okay, you have to show that this T is a linear transformation from Cn to Cm, because this script L, Cn, Cm is the collection of all the linear, it is a notation for collection of all the linear transformation from Cn to Cm. So you have to show that it is a linear transformation first, and then you have to show that every linear transformation from Cn to Cm, is of the form in some linear functionals. Okay, I mean you can represent any linear transformation T by these linear functionals f1 to fm on Cn. So how will you proceed in this question? First, you have to show that T is a linear transformation. Okay, so how will you do that in this question?
So we will take T of alpha v plus w.
Okay, so you are trying to show T is linear, right?
Yes, sir.
Okay, good. Now tell.
T of alpha v plus w will be f1 alpha v plus w up to fm alpha v plus w.
Okay.
Since we are given that f1 to fm are linear functionals, therefore they are linear transformations.
Okay. Yes. So you can say this T is a linear by using the linearity of these functionals, because these are the linear functionals given to you. So this is understood by everyone. This how will you show that this T is a linear transformation? Okay. All right. Any question? Any doubt regarding the linearity of this T?
No, sir.
Okay. All right. Now, how will you? Okay, this T is a linear. That is fine. Now you have to take any linear transformation from Cn to Cm. How will you show this? The part B. Any idea? So did you understood now the what to prove?
Um, so T is a linear transformation from Cn to Cm,
Correct.
where V is an n tuple. We take
Where?
V, small v
Okay.
is an n tuple belonging to Cn.
Mm-hmm.
We take V as V1 to
Can say
Vn.
vector. Yes.
V maps to, let's say V maps to a vector W in Cm.
Okay.
We take W as W1 to Wm.
Okay.
Then we will show that this vector W1 to Wm is equal to the vector F1V to F1 FMV. Then we will prove. Then it will be automatically proven that TV every linear transformation from Cn to Cm is of the given form.
Okay, so you are saying so this TV is a vector, so very much it is fine that TV is a vector which is of the form W, and
Yes,
W
sir.
we can write because this W is a vector in Cm,
Yes,
so it
sir.
is of this form W1 to Wm,
Yes, sir.
and if you assign this F1V, so if you because you have to find this linear functionals, because this T is given to you, now you have
Yes,
to
sir.
find the linear functionals corresponding to this linear transformation T f1 to fm, this functional that you have to find, and you have to define these functionals. So you define this functional f1 of w1 So f1 of w equal to w1, that you want to say. Okay.
Yes, sir. F1 of V equal to W1 and Fm of V equal to WM.
Sorry, f1 of v equal to w1, f2 of v equal to w2, and fm of v equal to wm.
Yes, sir.
Okay, so yeah, so this is one idea. Yes, that you can say. Any other? Good. So this is one way. So, but because you have to show that this is a linear functionals. Okay, you have to just verify this, all the reasoning that you have to supply. And is there any other answer or any other student who want to say? So one way can be like if T is a linear, so you know that if T is a linear transformation from Cn to Cm, then T can be represented by a matrix which is whose order is n m by n. Okay, so you can write this TV equal to AV. You can define this linear transformation in this way: T V equal to AV, where the order of the matrix A would be of the type m by n. So order of A is m by n. Okay, and if you just see the rows of this A matrix, you call those rows of this A matrix by A1 to AN, because this is M by N matrix, so there are M rows. Okay, M by N matrix, so A1 to AM you are having the rows of it, and you can define this F1 of V equal to A1 this A1 V, okay, and this F2V equal to A2V, and so on. Then again, these are the linear functionals. Then you can claim, and this T is represented by this linear functional. So let us see what I was just saying. It is blur, but I hope that the main idea would be clear. So T is a linear transformation from Cn to Cm. So we can represent, so that this is the main, I mean, the very standard result that you are aware of it, that Tx equal to Ax, where order of A would be m by n. Then you can partition this A matrix into these rows, this A1, A2, An, and this I represent this V vector by X, and so it's just a change of notation. You can take V also. So you can define this Tx in such a way, this A1x, A2x, and this Amx. So A1 is are a row vector, and this X is a like column vector. So you can define this F1x equal to A1x, F2x equal to A2x, and this in that way also you can show this statement. Okay, the last student who told the solution, that is also fine. Okay. All right. Any doubt regarding this? Are you following, all of you?
Yes, sir.
Yes, sir.
Okay. So okay. So let's move further to the question 3. So how will you do this question? So before so because this questions say it has a basis. This B beta basis is given V1, V2, V3. The basis for this vector space C3, where V1, V2, V3 are defined in this way, and this you have to find a dual basis. So what do I mean by a dual basis? Can anyone please quickly recall that? What is a dual basis of a basis?
Uh, if a basis of a vector space beta is given such that beta is V1 to Vn, then beta dash, which will be equal to F1 to Fn, will be a dual basis of beta if Fi Vj is equal to del Ij.
Okay. Okay. All right. So del ij, but okay, I understood del ij is a Kronecker delta, where this is equal to 1 when I equal to j, and this is 0 when I is not equal to j. Okay. So that is fine. Now, how will you find this basis?
So take arbitrary element of CQ, x1, x2, x3. Then we will find x1, x2 can be written as alpha 1 v1 plus alpha 2 v2 plus alpha 3 v3.
Right.
Now we operate f of 1 because we take f of f1,
V1.
f2 and f3.
Yes.
Then we operate f of f1 v1 is 1 and all is 0. Then we get f of f1, x1, x2, x3 equal to alpha 1, and similarly f of 2, x1, x2, x3 equal to alpha 2, and alpha 3, x1, x2, x3 equal to alpha 3. Now we will find the values of alpha 1, alpha 2, and alpha 3 in form of x1 and x2 and x3. Hence we done. Because we know that x1, x2, x3 is
You
a
have to
linear
find the
combination
basis,
of.
right? You have to tell at last. You have to tell me 3 vectors of the dual space which forms the basis. Okay. So in spite of doing in general in terms of x1, x2, x3, you can do it for, because v1, v2, v3 are given. So you can say f1 of v1 equal to alpha 1 plus this alpha 1, alpha 2, alpha 3 multiplied by this vector 1, 0, minus 1. This is equal to 1. So let me tell you what I was just trying to say. So here, so what I was saying that this, you can, if you want to tell me the basis vectors of the dual space, then you can say this f1 of, and this is v1, f1 of v1, this is equal to alpha 1, alpha 2, alpha 3. You know that this is a fundamental result. If you, any functional can be represented in this form, summation alpha I vi. So here basically not vi, not that, but you can represent this linear functional in this way, and this multiplication would be 1 according to the dual basis. So you may have, and this f1 of v2 is 0 and f1 of v3 equal to 0. So you have this kind of linear system in terms of these 3 variables, alpha 1, alpha 2, alpha 3. You can find these values alpha 1, alpha 2, alpha 3, and so this is your the functional, the f1 functional, which is an element of the basis, the dual basis. And similarly you can find f2 and f3 that you have to solve. So what you are trying to say, that is also correct, but it is basically in general sense, and that is also correct. I just trying to say that you can do in this way also. So is it is the problem clear? Is how will you find this dual basis?
Yes, sir.
Okay. So how about this question 4? Here you need a general argument that the earlier you trying to say. What about this question 4? How will you find the? So first of all, you have to show that this forms a basis. Okay. Whatever the things is given to you, that forms a basis for B dash. How will you do this?
Sir, we take alpha 1 f1 plus alpha 2 f2 plus alpha 3 f3 equal to 0. Now we will prove that alpha 1, alpha 2 and alpha 3 all are 0 because we are showing its Li. And then we operate firstly x, then x, firstly operate 1, then x square, because it is standard basis of P2R.
Right.
And then we will find 3 linear 3 equations. And then we get alpha 1, alpha 2 and alpha 3.
So you are so whatever the arguments just you said, that was regarding to proving basis, right? Or you have told me this, how will you find the basis B corresponding to this dual basis given? Because here the basis is given for the dual space, right? For the dual space, so V is a vector space. It is a collection of all the polynomials of at most degree 2. Okay, and Px, you can represent Px in this form. So first of all, you have to show that this B dash, whatever the set f1, f2, f3 consisting of, is given, you have to show that this forms a basis for V dash, where V dash is the dual space, and then you have to find a basis beta for this vector space P2R, such that this V dash, whatever the given dual base, the basis for the dual space, this forms a dual basis. Okay, dual basis. So that is fine. You can show that this B dash is a basis for V dash. I mean, sorry, beta dash is the basis for V dash. That is fine. How will you find this basis for the corresponding dual space?
सर पहले v1 एक एलिमेंट को डिफाइन करेंगे a0 प्लस a1x प्लस a2x2 और सच दैट कि f1 v1 जो होगा वो 1 होगा बट f2 v1 0 और f3 v1 0 होगा. अब जो यहाँ पर हमें इंटीग्रेशन जो f1 f2 f3 की वैल्यूज हम पुट करेंगे तो लीनियर इक्वेशन आ जाएगा, उसमें हमें a2 a1 और a0 की वैल्यू आ जाएगी, तो हम v1 निकाल सकते हैं ऐसे.
Right. So yes, so I mean, whatever you are trying to say, that is, I mean, I am understanding. What about the other students? Are they getting how to find this B dash? How to find this B? Sorry, very confusing.
Yes, sir.
Yes,
So, so what she said just is that because this one vector is given 0 to 1, this px dx. Okay, so you can say this px, the value of, I mean, you can represent this px in this form, c0 plus c1x plus c2x square. And if you solve this integration, then this comes out, this c0 plus c1 by 2 plus c2 by 3. And similarly, you can do it for 0 to 2 px dx, and you come out with this, and minus 1 to 0, and this px, and you are having like this c0 minus c1 by 2 and plus c2 by 3. Okay, and you can write, I mean, because these are the values, so you can write this is equal to 1 0 0 for so this much of system, and you can change this vector 0 1 0 and 0 0 1 to just find. So basically, so this way you can also do it. You just apply whatever the row. So you just reduce this matrix, this augmented matrix, into this echelon matrix form, and you, I mean, in this way you can also do. That might be easy. I haven't done further, but that is the main idea. So in that way you can find that basis. Okay. So is this clear, right?
yes, sir.
Yes, sir.
Okay, but what I will you suggest, you just do all these problems by, I mean, at your end completely. It is not like you just left those problems. It is for your practice, and you can try few more problems from the textbook, that is, which is the Hoffman and Kunz. You can find some more variety of these problems, and you just have some practice, so you can have a grip on these type of problems. So moving to this question 5. Okay, so it involves this annihilator of W. So what do you understand by annihilator? Because that's what it has been asked in this question,
sir.
annihilator of W.
So if V is a vector space and W is a subset of V, then there exists W annihilator, which consists all functions such that f of V equals to 0 for all V belongs to W.
All V belongs to W. Yes, correct. So here, all of you can, I mean, notice that this W may not be a subspace of this V, because what she said is W is a subset of vector space V, and this annihilator of W, which you can represent by W0, and this is always, you can check that this always forms a subspace. Okay? Annihilator of W, which always forms a subspace. Now, how will you find this? Because in this you have to find the annihilator of W, right? How will you do this? So you can just apply the definition. So basically what the definition says, f of v equal to 0 for every v in W. So, and the W, what does this W comprises? It is a span of these two vectors, right? The span of these two vectors, this 1, 0, I mean the span of v1 and v2. So you can write this, this can only possible when this f of v1 equal to 0 and this f of v2 equal to 0. Okay, so then when you write this f of v1 equal to 0, this would be c1 minus c3 plus 2 twice of c4 equal to 0, and this 2 c1 plus 3 c2 plus c3 c4 equal to 0. Now you can treat this as a subspace of the vector space, okay, of this the dual space, and you can find what is the basis for this subspace. Can you find the basis? Can you find the
Yes,
basis
sir.
for this subspace?
Yes, sir.
Because it is very, I mean, it is not difficult. So if you just apply the definition and you just follow the steps, then you can easily find the basis for this subspace. Okay, in terms of, because you can, I haven't done it further, but you can write this c1 equal to, because this okay. So before telling me the basis, can you just tell me what is the dimension for this W naught?
2, sir. 2.
2, sir.
Is it correct? 2?
Yes, sir.
Okay. Okay, so in that way you can answer it. How will you find this? You can write this C1, C2. I mean that is a basic way in terms of C3 and C4, and this C3, C4 are two free variables. So you can write the basis. Okay, so that is one idea. So this question 5 is also comes by the definition. What about this question 6?
सर सिमिलरली 5 जैसे
हाँ.
कर सकते हैं ना.
Similarly, you can do. So it is basically the large version of the previous problem. So it is for your practice. You can try this. So here you can sorry. Here instead of this, these are the three equations you got because you have three vectors given over here, and just write this properly. And so what is the dimension here of W naught? If I ask you.
सर 2.
2. So which results so there is basically a fundamental result regarding this W and the annihilator of W is a subspace.
Dimension of W plus dimension of W naught is equals to dimension of V.
Dimension of the vector space, but there this W must be the subspace, right? That what is given. So this question, sorry, this question you can also do by this definition. Okay, all right. So okay, so question number 7. How will you do this? So here the vector space is given collection of all the 2 by 2 matrices over this real field, and this B vector is given, that is a fixed matrix, and W is so all the matrices, so that if you multiply that matrix, all the matrices which you multiply by right side by B, this would be a null matrix. And this F, if F would be in the annihilator, then these two, with these two assumption, you have to find this F of B. Is the problem clear?
Yes, sir.
So how will you use these two conditions, f of I equal to 0 and this f of c equal to 3, and you have to find this f of b. Okay, and f is in the annihilator of w, and w is a space here which is defined over here. If you multiply any matrix from the right side by b, then it is a zero matrix.
सर सर यहाँ पर गिवन है ए बी इक्वल्स टू 0 मैट्रिक्स। तो ए को कोई भी जनरल मैट्रिक्स ले लिया है और उसको बी से जब इनटू किया तो 0 आना चाहिए। तो उससे ए का फॉर्म पता चल गया। तो ए मस्ट बी A1 2A1 A3 2A3 टाइप का होना चाहिए। तो मतलब कह सकते हैं कि A1 इक्वल A1 1200 प्लस A3 0012 इस फॉर्मेट का। उसके बाद बी को हमने A1 और आइडेंटिटी मैट्रिक्स और एक और जो मैट्रिक्स हमें गिवन है C उसके टाइप में लिखा, और जब हमने उसमें F अप्लाई किया तो आंसर 0 आ रहा है।
So at last, what is the solution you get? What is f of b?
0 सर 0।
0. Okay. Yeah. So is it clear to everyone? How will you get this? So you have to write this. So basically, you have to use this condition. I mean, these two conditions: f of I equal to 0 and f of c equal to 3. And this, of course, you have to see what is the kind of this matrix when you take from this W. You have to multiply this matrix. You can take this A matrix in this form, A1, A2, A3, A4, and you multiply by right side by this matrix B, and you see what is the type of this matrix. And then when you see f of I equal to 0 and f of c equal to 3, and you just write this B matrix in these two terms, then you can get this f of b equal to 0. That is not difficult. Okay. Any doubt? So, all right. So, moving to further, this question number 8, which is the last question of the sheet, I think so. Yes. Okay. So, S is a subset of a finite dimensional vector space. Then we have to show that the span of S equal to S double. So, basically, you can say it is a double annihilator, or it is an annihilator of this S naught. Okay. So if S, let's say if S is given to be a subspace, then you don't need to take this span. So how will you? I mean, is it proved in your class lecture?
Yes।
Yes, sir. Yes, sir.
Okay. So can you just recall that? How will you do this from that reasoning? If it is not very far, I understand that you might have some more classes, maybe discussed very earlier. But if you can recall, then please can you just recall that to everyone? This S is a subset of a vector space, that you can, from that you can start.
सर एस सबसेट है, तो इसके करस्पॉन्डिंग हमें एक एनिलेटर मिलेगा, सपोज W नॉट। तो उसमें सारे फंक्शंस रहेंगे सच दैट f of W इक्वल्स टू 0 फॉर ऑल W बिलोंग्स टू S। सर तो सर इस W नॉट के करस्पॉन्डिंग हमें W डबल नॉट मिलेगा, वो हमें V डबल डैश में मिलेगा। अब सिंस वी डबल डैश और वी आइसोमॉर्फिक होते हैं, तो इसके जो एलिमेंट्स हैं उन्हें हम कनेक्ट कर सकते हैं वी के एलिमेंट से। तो इससे हम ये शो कर सकते हैं कि कोई भी एलिमेंट अगर हमारा एस का है तो वो डब्ल्यू डबल नॉट में भी बिलोंग करेगा। तो एक तरफ से कंटेनमेंट हो गया, उसके बाद इनका डायमेंशन सेम दिखवा देंगे तो फिर आ जाएगा।
Okay, so you have told me the roughly the what is the main idea. So what I can suggest you can start with this S is a subset, okay? But this S can be empty also. If this S is empty, then what is, because empty is also, empty set is also the subset of a vector space, right? So then what is this S naught? What would be this S naught if S is empty?
V days, sir. V days.
Zero,
Huh?
zero subspace.
So if S is empty, then what would be this S0, annihilator of this empty set? There are many ways, I
Sir,
mean,
sir,
to guess
whole
this answer.
W V dash. The complete V dash.
Complete V dash, correct. So you can, I mean, you can bifurcate this these two cases. If S is empty, then this is, and if it is non-empty, then you can start with, okay, it has a finite element, so you can start with. So you can say this is an annihilator, and then you can define this isomorphism between the dual double. I mean this isomorphism from this S double naught to this subspace of the vector space. Okay? And then you can show that this the span of S equal to by using the containment, of course. One side is fine, but other side. But what is a basically you can you just focus on these two things. If S is empty, you that I mean you can write in two cases. That much I wanted to tell. Okay, so this sheet is complete from my side. If you have any doubt, you can always write to us regarding this. Okay. Have you tried the
Okay,
other
so
problems?
Mohit,
Yes.
yeah, so I need at least 10-12 minutes because they had some doubt in the morning class. So maybe because you are done with this tutorial sheet, so may I take
Yes. Yes. Sure. Of course.
I take the next 10 minutes. Okay. So you can, so first of all, I want to make this announcement that since I have already uploaded tutorial sheet 5 and you are still like done with tutorial sheet 4, so you have yet to start tutorial sheet 5, and in the next week I will upload another one, so you are still behind. So what is the suggestion? The suggestion is that students should try these problems themselves because the tutors may not be able to cover all the problems in the class. So it should be like you try out these problems at your end, and then whatever doubt you have, that you can discuss with the tutors. Because if they start doing all the problems for you, then it's very difficult to cover all the problems in the given time. So what will happen is that at the end you will be left with 2-3 problem sheets which are not discussed in the class. So it's better that you start doing it yourself and come up with your doubts in the tutorial class, and your doubts can be discussed. Otherwise, if you don't discuss in this way, then it will take more time. We don't have any issue. The only thing is that we won't be able to cover all the problems. Okay. So let me, so in the morning class, you asked me that why, so while proving this column space, column rank of a matrix is equal to row rank, I use the dual basis of Rm, which is like the standard basis of Rm. So let me first write the doubt so that everybody can understand, and then I'll explain why these things is, why I did it in this way. So in the morning itself, I mentioned that you can actually define isomorphism from Rm to its dual space, and then you can actually identify Rm, the dual space of Rm, as Rm itself. So let me share my screen, and then I will write the doubt, and then I'll give you the idea and you can complete, you can work on it and then you can convince yourself. So I'm sharing my screen now. Can you see my screen?
Yes, sir.
Okay.
Yes, sir.
Yeah. So now if I, so let me just open a new file here. So if I prove that Rm can be identified with its dual, by its dual, or it's the dual of Rm or Rn, if it can be identified by its by Rn, then your doubt is clear, right? So, or you can say that why the dual basis of E1 to Em is same as E1 to Am itself. This is the doubt you had in the morning. Right? Am I correct? This is the doubt, right?
Yes, sir.
So, okay. So if this is clear, then things are clear. Now, what I'm saying is that you can actually, what you can do, you can find or you can define an isomorphism from Rm to its dual space. Okay, so what we want to do, so the idea is, so this is the idea, and then we will work on this idea. So idea is that we want to define an isomorphism, let's say T, from Rm to Rm dash, its dual. Okay, so that means we have to, here we have vectors, so m tuple vectors, and here we have functionals defined on Rn. Okay, so we have to relate the vectors here with the functional. So what we can do is that let's say if I take any vector alpha, so this is the idea. So I have to send alpha. If I take any vector alpha in Rm, or let's say x in Rm, then I have to send it to some function, let's say fx in Rm dash. So this functional I have to define based on this x. So what I'm saying is that we can do it something like this. For example, if I take, let's say, x in Rm, so x in Rm would be of the form x1 to xn. So it's an m tuple vector. Okay. Then depending on this x, I have to define a functional on Rm. So let's say fx I want to define on Rm. So it's a functional on Rm. So um, we have to define it. So how can we define? Can you give me some idea? If I take, let's say, any vector here in Rm, so let's say alpha, where alpha is of the form alpha 1 to alpha n. Can you give me some idea to define a function on this using the information we have so far?
Alpha 1, alpha 2.
No, alpha, we have to define a functional. So that means linear map from Rm to R. And this function should be dependent on this x because we want to relate vectors in Rm with functional. This is what we want. No? We want to define an isomorphism from Rm to Rm dash. So we have to relate elements here with the elements here. This is what we want. So what we can do here?
So X transpose a product with alpha.
So yes, so or in other words, when you open this, it would be like summation xi alpha, right?
Yes, sir.
Yeah. So now you can verify that this is a well-defined function. It's in fact a functional. That means it's a linear map from Rm to R. So for every x in Rm, you can define fx. That means a linear functional on Rm. So now you have sort of idea that okay, now if you define this this linear this isomorphism which you are intend to define, so what you can do, you send this any vector x here to this map fx. Okay. Now if you do it in this way, then you can like verify that this map T which I have defined here, this T is an isomorphism from Rm to Rm dash. Okay, so you can verify that this T is an isomorphism. That means it's a linear and 1 1 because Rm is finite dimension, so 1 1 is same as 2. So here you can say this is easy to verify that T is linear, and you can also verify that T is 1 1 or T is onto whatever. So T is an isomorphism. So now this is an isomorphism. So you have a way to relate vectors in Rm with the functional on Rm. Okay. Now come back to our, so this is the idea that we know we have a isomorphism between Rm and Rm dash. Now come back to our main question, that why the dual basis of this E1 to EM standard basis in Rm is the same basis itself. Now why this is true? Let's why this is true. Now let's say we take standard basis, let's say alpha n, or no, E1 to EM. So let's say so let E1 to EM, this is a standard basis. This is in Rm, right? We can take this. Now this is a basis in Rm, so we can find its dual basis in Rm dash. Okay, so what would be the dual basis of this? Let's say F1 to Fm. We can always find, right? So let's say F1 to Fm. This is the dual basis of, let's say this is B and this is B dash. So B dash, these are the functionals. So this is a dual basis of B, which is a standard basis in Rm. Okay, so this is a dual basis of B. So these are functionals on Rm. Now what we know that this F1 to Fn, they belong to Rm dash. So these Fi's, they belongs to Rm dash. That means the dual space of Rm for each I. And because of this isomorphism, what we know that there exists, let's say alpha 1 up to alpha n in, on, if alpha is, we are calling a scalar. So let me, so you can write that there exists x1, x2 up to xn. So that is also not the right notation. So let's say v1, v2 up to vn. So there exists v1 to vn in Rm. There exists v1 to vn in Rm because of this isomorphism. We know that these Fi's, they belong to here. These Fi's belong to Rm dash here. So because of this T, we know that there exist some vectors for each I. There would be one Vi such that T of Vi is equal to Fi. Right? So what we can say that there exists V1 to Vn such that this Fi is equal to F of Vi for each I equal to 1 to n. Is it okay? Is this okay?
Yes, sir.
Because of this isomorphism. Now this is fine. Now what we know that this Fi, this B dash here, this forms a dual basis. This forms a dual basis. That means what? That means Fi Ej is equal to del Ij. But Fi, we know what Fi. So the left hand side would be F Vi Ej is equal to del Ij. Right? But then you look at the definition of this F subscript Vi Ej. So you go back to this. Now look at this, what it is. So if I denote, let's say Vi, so if I, let's say, sorry. So if I denote, let's say Vi, let's say for each I, Vi is of the form this. It has Vi1, Vi2 and so on up to Vim. It is a vector. Vi is a vector in Rm, so it will have m component, right? So let us denote it in this way for each I. So now if you go back to our definition of this function here, what would be f bi ej? Can you tell me what it would be? Ej is what? Ej also you know. Ej is this 0, 0, 1 at
Sir,
jth
Fij.
position. So it would be Fij. Not Fij, it would be what?
Sir,
It would be
Vij.
Vij. So it would be just Vij. So Vij equal to del ij. Now can you tell me what it would be? So this implies that this Vij is actually 1 when I equal to j and 0 everywhere. So for other I, it is 0. So basically this Vi vector, you can say, what would be this Vi vector from here you can say?
Yeah.
What would be this Vi?
I.
Not I,
Ei.
it's Ei. Ei. And this is true for each I. Right? Now you can see that because of this isomorphism, these vectors, these linear functional f1 to fm, which you were identifying by the vectors v1 to vm, if this is a dual basis, then this v1 to vm turns out to be e1 to em itself. Did you get my point? So from here you can say, because of this isomorphism, if you identify rm dash as rm, then corresponding to this linear function f1 to fm, the vectors in rm are e1 to em itself. So you can say that in this sense, when I say that dual basis of e1 to em is e1 to em itself, that means I'm saying it in this way. And therefore, you can say, you can answer this question that dual basis of E1 to En in Rn is the same basis itself. Does it make sense?
Yes, sir.
Okay. So I think this answers your question in the morning class. So again, I'll repeat that you please work out the problems. At least you try, so that you have some doubts. You collect your doubts and you come up with your doubts in the tutorial class. So that way we can fulfill the purpose of this tutorial session. Okay. So I think we can stop now, and I'll see you on Thursday in the lecture class.
सर आज की
Yes.
सुबह की क्लास का नोट्स अपलोड कर दीजिएगा.
Yeah, I'll do that. I'll do that now.
सर MS Teams पे प्लीज.
Okay. Anything else?
No sir, thank you sir.
सर
Okay.
my note के आंसर में सर प्रॉब्लम है सर, वो मैंने रीगेट कर दिया तो सर वो मेल भी करना है क्या अलग से? Regate is sufficient.
Yeah, so I have not gone through the regrading yet. So the regrade request is still pending. I know that. So I did not get time to go through this. So I'll do it whenever I get time. So you'll get the notification. Okay. Okay, so let's stop here. Yeah, see you.
Thank you, sir.
Yeah, bye.